Hello, I'm Dr. David Kordowitz, and welcome to Programming. Today we're going to discuss another essential component of writing programs, loops. Loops allow you to reuse code that you've written multiple times within the same program without having to write it over and over and over again. So let's begin. So the general idea is that you need to be able to sometimes run something multiple times. For example, if you want to average a series of numbers, the first thing you need to do is add them all up. So you might need a loop to actually go through the numbers and add them up. We'll demonstrate this in a little bit using our Arduino, but for the time being, just think about the concept of being able to do something over and over and over again. Loops do this in a very simple and concise manner. There are basically three types of loops. Some people say two types of loops, but the first type being while loops, which are conditional loops, and they'll run while some condition is true. The second type are for loops, which will run for some set period of time or number of iterations. Now, this set iteration length could be set by the program itself or can be pre-written into the program depending on exactly what your needs are. The last type are infinite loops, which will run forever until something interrupts them. While loops come in two varieties in the C and C++ language set. The first type is a standard while loop, which begins while, and it has what the conditions are for the while to continue to run. You then have curly braces, which contain your code. This is what we call a pre-check loop. What this means is that the condition is checked at the top of the loop every time the loop goes around. That means that if the condition is not true the first time the loop runs, the loop won't run at all. This is because the pre-check will always check at the beginning of the loop. As opposed to this, we have what we call post-check loops, which in C are do-while loops, and do-while loops will check the condition at the end of the loop. That guarantees that that loop will run at least once. Now, it's important to note that when you're looking at this, do-while loops tend to be more the exception than the rule, and most people will try to avoid these by forcing the condition to be true, at least in the first iteration. Additionally, it's important to note that in a standard while loop, there is no semicolon after the while statement or after the curly braces. If you put a semicolon at the end of the while statement, your entire loop will execute only on that semicolon, and it will become some form of infinite loop. For loops, however, will take in some conditions and will run for some iteration. So in this case, we start with the statement for. We then have what our starting condition is, our ending condition, and then our iterator. So our iterator basically is how we're going to increment between the individual steps. The loop shown below here starts with for n equals 0, so that means at the beginning we're going to set n equal to 0. We're then going to continue to run while n is less than 100. And each time you go through the loop, you're going to run n++, or n is going to equal n plus 1. So what this means is this loop will run exactly 100 times with the value of n being equal to 0 to 99. Now, each iteration, you can use the n inside your loop. Again, we'll demonstrate this when we do our demonstration with the Arduino. The last type of loop that we need to think about are infinite loops. Infinite loops will run forever unless they're otherwise disturbed. You can use either for loops or while loops to create infinite loops. And in the case of for, you just put no starting condition, no stop condition, and no iteration. In the case of a while loop, you're just simply going to put while true or while 1 or anything that will guarantee that it computes out to being true in every case. So I've seen before people say while 1 equals 1, and 1 will always equal 1 because hopefully your numeric system isn't changing. However, infinite loops are useful to a point. Infinite loops are useful for running repetitive tasks. However, at some point you need to be able to get out of the loop to be able to move on with your program once conditions are met. So we have two commands that can help us with this. The first one is the break command. The break command will get you out of any loop that you're in. This works for loops, this works for while loops, this works in infinite loops. So anytime you're in a loop, If you run the break command, you will jump out of that loop and break the loop. We then also have the opposite of that, which is the continue command. The continue command will take you to the top of the loop and start the next iteration. Continue is generally avoided by most programmers. However, it's there, and I've used it before writing my own programs. So let's take a look at this code on the right so that we can better understand what's going on. We declare a variable called n, which is going to be our iteration variable. You can declare n in the for loop line. However, it will only be in scope for that particular for loop, where if I create it at the top like this, it will be in scope throughout the program. I'm then creating an array m of integers containing 128 elements. In fact, in this case, I'm not using all 128, but it's nice to know they're there. We're then creating a for loop, which goes from 0 to n less than 10. So in other words, we're going to have 10 iterations where n starts at 0 and n ends at 9, and we're going to step by ones. We then declare a temporary variable that will be only in scope in the loop called k, which is going to be a temporary storage for a reading that we get. We're then using our analog read to get a value from port A1, and then we're going to evaluate that to decide what we need to do. If k is less than 0, we're going to break. It turns out that k can never be less than 0 because of how the A to D converter works. However, in this case, we're saying if it ever does, get out of the loop because we don't want to know anything about it from there forward. If k equals 0, we're saying continue. So we're just going to reject that particular reading. If we have a k greater than 0, we're going to store that into m of n. N is the current iteration. So that means we're going to start with 0, 1, 2. And then we're going to go ahead and print the value we've recorded. So let's break this down a little bit. If k is less than 0, we're going to break, which is going to get us out of here. And we're going to continue on the program below. If k is equal to 0, we run continue. Continue will take us back to the top of the loop. It will iterate n to the next value, and it will start this program over again. This print line will only run in the case of the else statement. In general, this isn't necessarily considered to be the best way to do this because it really is part of the else. Although with the way we've restricted things here, the else is entirely unnecessary. So let's take an example here using our Arduino. For today's example, we're going to take a bunch of readings from a temperature sensor and we're going to average them together to determine the local value. To do this, we're going to start by defining our temperature sensor port. To do this, we're going to use #define, and the port, we're going to call it TS, and the port that we're on is A9. In addition, we're going to define our ADC number to voltage, ADCTV, as 5.0 divided by 1024. This is going to allow us to convert to voltages. So the setup on this is going to be relatively easy, although we are going to use the serial monitor to display our output. So I'm going to start with serial.begin 9600 because we want to run at 9600 baud. And now we're going to do a while not serial. Now it's important to note that I put a semicolon after the while loop here. What that does is it executes that semicolon until the serial monitor is open. So until our serial port's all connected, we're going to get stuck at that location. So basically I'm building a infinite loop that runs nothing until we open up our serial monitor. This is useful in this case. However, previously we've stated that you should never put a semicolon after a while loop. This is true. However, in this case, it does exactly what we want it to do. Let's go ahead and declare a floating point operation or floating point number or array that we're going to call temps. And we're going to make this be, say, 128 in value. What we're going to do is we're going to collect a series of 128 temperatures at each data point, and we're going to average those together, and then we're going to delay between reads. This is a very common practice when you're measuring analog signals, because it allows you to average out the error very quickly, however have a time period between samples. So what we're going to do is create a for loop. So we're going to say int n equals, or int n, which is going to be our for loop iterator. We're going to say for n equals 0, n less than 128, n plus plus. Now what we're going to do is start collecting our values. So we're going to say, okay, well, temps of n is going to be equal to ADCTV times the float of analog read of our port TS. So what's going to happen now is this is going to fill that array with values. So now, once we do this, we're going to put some delay in between the values, say like 10 milliseconds. So we can do delay 10 milliseconds. And that's going to mean that we're going to collect these for 10 milliseconds. So this entire reading is going to take somewhere on the order of 1.2 seconds, 1.28 seconds. Now what we want to do is run our average. To do this, I'm going to create another variable, which in this case is going to be a float that we're going to call average. And so what we're going to do is we're going to sum up all of these values. We need to be careful here that the values never exceed the float max. If you want to ensure this, an easy way to do it is to divide each of the values by the 128 as you're adding them up. Remember that division is somewhat commutative with addition in this case, since we're summing up the values, dividing them by 128, which would be the same as dividing all the values by 128 and summing them up. So let's create another for loop. Now I can reuse the variable n because I've already created it and declared it within this scope. You can also note that you can actually have multiple for loops inside of each other. This is called nested looping, and it works really nicely for when you're doing things that require you to iterate through 2 dimensions or something like that. So what we're going to say here is we're going to say that average plus equals, which is average equals average plus whatever we put next, and we're going to say that that's going to be temps of n divided by 128. This will then go through and sum this up. However, since we haven't predefined average as being equal to 0, this really isn't a valid argument. So let's just say average equals 0. That's going to help us initialize it so that as we add this up, we're actually adding based on real numbers. The last thing we're going to want to do is display our result. So to do this, I'm simply going to use the serial.println command, and that's going to be the average. Now, it's important to note that there seems to be an extra curly brace here, and that could be a problem, so we're just going to go ahead and delete that. And this program should be complete. So let's go ahead and write it to hardware and see what happens. So now I've applied my finger to it and I'm heating it up slightly. And you can notice that the temperature is going up. If I let my finger off, it's going to start coming back down. This means the temperature sensor is working correctly. Now, if you notice, this is an average of 128. It's only showing 2 decimal places. Again, if you remember from previously, we can use some of the commands to be able to show more decimal places. So this gives you more significant figures, and as we know, because we're averaging these together, we have a little more information than we normally would. I'd like to thank you for your time today, and see you next time.